Well, now we can roll straight into part 2 of that discussion, which will be a little bit more focused on Kubernetes. So I will hand it off to John.
Hi, everyone. Excellent. We have a new Etherpad. So the top few lines here are a couple of polls. So just as we sort of get started, if people want to try and pile in with their +1s or -1s with a comment, are also welcome. So I should quickly introduce myself while that's going on. Actually, we can kick off. Would someone on the foundation like to kick off the poll for us for the next poll?
Yep.
That'd be awesome. Oh, star. Thank you. So I'm seeing people come in. Thank you. So I'll introduce myself quickly. I'm John Garbett. I work with Stack HPC. We focus an awful lot on HPC and OpenStack and how to make that all work well together. My experience with OpenStack goes back almost getting up to the 10-year mark now. Been various things over the time, including NovaPTL and TC Member and Nova Core. But yeah, hoping to have a good discussion about Kubernetes and OpenStack today. Okay. So we've got about 43% of the people voted so far. Excellent. Some more votes coming in. Okay, so while we're doing that poll, I just wanted to go down to this line 55 and talking about sort of how you actually look at running Kubernetes, generally speaking. So this, I guess, is actually a question more about how do you deal with Kubernetes multi-tenancy. I don't want to drop someone in it, but Spiros, are you still on the line? I don't know if you wanted to share how many clusters you have at CERN, just to put some information behind that tweet from Tim.
So I think it's around 500. So this number changes frequently, and I'm opening Grafana as we speak. So it's around 500 and over 2,500 servers, and in course even more. Let me log in. I will tell you the exact number. In the meantime, we can maybe continue.
Yeah, no worries. Sorry to drop you in it. So I guess in your case, you're so one of the advantages of Magnum is you can walk up and just press go, and there's quite a few ways of doing that that people are currently voting on, as in making it easy to quickly get a Kubernetes cluster. So I guess, are you seeing users generally all wanting their own cluster, or having more sort of the approach of multi-tenancy within the cluster?
So yeah, so the numbers were the exact ones that I mentioned. It's like 510 clusters, 2,500 nodes, around 10,000 cores. So yeah, with Magnum, just as you said, it's one click to create a cluster, like, or one CLI command, and then there are two patterns users can follow. So the easiest one is one cluster, one tenant, and then many clusters, because it's trivial to create many. So this is the pattern of clusters as cattle. So you have like a fleet of clusters that are small and flexible, and they can come and go. versus like a big multi super HA cluster that might be HA regarding failures in hardware, power, network, but one wrong configuration can hit the entire cluster, or if you compromise the massive cluster, you can compromise almost everything. So yeah, this is like the pattern that Magnum allows the cluster API and Rancher as well. I allow this pattern. Could phrase another way and KubeADM, but this is mostly the operator or the consumer of OpenStack is doing most of the work regarding setting up monitoring and so on. While in Rancher and Magnum, you have a lot of packages kind of pre-installed or components in Kubernetes, and with Magnum there is one layer higher than Rancher in the sense that all the accounting for Kubernetes is already for OpenStack that interacts with Kubernetes, like the tenant, the project, the delegation to application credentials or trust users is already there, while in Rancher you have to do some extra work for that.
That's an interesting point. So people are doing disposable clusters, but still wanting to use like app creds to talk to the Kubernetes API.
Yeah.
Or did I misunderstand?
This is a way to upgrade your infrastructure without touching the existing one. So you add extra capacity with new configuration and new versions without touching the old one, because if you go for minor releases, it's safe to do an upgrade. With Magnum, it's pretty easy to do it, and other projects, of course, as well, because the differences in versions is very small. But if you want to jump into other to either new hardware in your underlying infrastructure, or if you want to jump two versions in Kubernetes, you might want disposable clusters and add capacity gradually and remove the old one, as you would do with VMs.
Cool. We're getting quite a few good questions also in the Zoom chat. And I'm going to open in the floor to answer the questions. So there's some questions about edge computing scenarios and what strategies people are doing for their deployments there, what limitations they create. I'm also seeing lots of +1s from non-Magnum based tools. So I was wondering if someone from like Rancher or KubeSpray or KubeADM, anyone that's +1 those, if you wanted to say, you know, what you're seeing. Are you seeing these disposable clusters as cattle, or are you seeing sort of longer lived clusters and that kind of thing? Also, last few minutes or seconds for people to vote in the poll. So I think it's kind of interesting.
Yeah, it's mainly because Rancher and KubeAdmin, mainly because they are Rancher for simplicity and KubeAdmin is mainly you can customize. Those are the reasons why we choose that.
Okay, so a mix of both.
Yep, that's right.
Interesting. So for your clusters, are you seeing a mix? You seeing a mix between the long-lived clusters or clusters as cattle, or is it mostly clusters as cattle?
See, in the labs, we just they are all cattle. We just bring them and take them off. Not in the production, but in the production they are long live usually.
So maybe that's a question to back to Spiros, is if you're doing these clusters as cattle, how do you deal with like migrating workloads between your cattle clusters? Maybe you don't do that. I'm thinking like when you upgrade.
So there again, you need some kind of proxying and some business logic in your proxy. Recently, we are pushing also upstream to the cloud provider to be able to join different backends for in service type load balancer of Kubernetes. So if you have Octavia or something else to serve load balancing as a service, you can have different clusters there. And
Oh, so in that case, would you have like two different? You'd have like your A and B cluster both being behind the same Octavia load balancer.
yeah, that's possible. Or if you don't do that with with Octavia, you can do it with another proxy, Nginx, HA proxy, or anything really.
Like, so
And
your proxy would be
define
outside of your Kubernetes clusters in this case, or?
Yep, in that case, would be either in Octavia or
Or in
another
a separate
managed load balancer. This is what we do for VMs at the moment, so it's almost the same. Either you manage the proxy with a tool like Ansible or even by hand, or you move that business logic to the cloud provider, the OCCM, the OpenStack cloud provider, cloud control manager for Kubernetes.
So to do that, so to do this whole Octavia shared between two clusters, I guess, how do you do that without OpenStack cloud provider changes? Is that not possible right now? I guess you could do it between the pod IPs.
It's not merged this work yet, so we are discussing it upstream. We have done some tests already, and it's pretty straightforward. But if you don't have the cloud provider working or supporting this, you can either have in each cluster an ingress, or even a service type load balancer per cluster, and then in front put another HA proxy that you manage by hand. This adds some overhead. So the easiest one would be to have an ingress controller in your cluster set with node port or service type load balancer, and in front put HA proxy or your proxy, the proxy of your choice.
No, that sounds good. No, good context. Thank you. So maybe going back to, so Prakash, I think you mentioned about having long-lived clusters for apps in production.
Sure.
I'm just wondering if you wanted to go through what the main driving reasons for that were. Is it just that the apps in production don't get changed as much?
So the issue is obviously setting up once and running tests again and again is one. The other is once you establish, you only want to upgrade when the new Kubernetes, like 1.8 to 1.9 or 1.7 to 1.8. So upgrades are the only reasons we want to maintain. Once you have the other factor, obviously load balancing, as you mentioned. Example, if you have Nginx, then you use whatever Nginx itself supports. But node ports are risky. We don't prefer. So whether we use a ingress controller or a load balancer, obviously I have not tried some of these like Octavia. I know for long, but not tried it. Preferred somehow to go with HA proxy, which has been traditional. And so what I see is it's always the question of scaling. And that's one of the reasons you stay put on one for longer time. The other is upgrade. Or I would say, like example, Go changes, Go 1.3 to 1.4, then you are again stuck. You don't want a lot of changes together, but you want step, what do you call, selective upgrades. And so for a long term, we prefer to go with selective upgrades and test it before we really change the production. So this is more to do with the business criticality of the cluster, and obviously we do have also to worry about sometimes on the what do you call the VIO part of it. So when we have VMware and Red Hat and combination thereof is more challenging.
And
But
maybe just to probe into that slightly, is that within a single Kubernetes cluster?
Usually not, but we do get asked for it, and so we do experiment. Yes, we can do it. It's not like you cannot do it. You can do it, but that is the provider network part which we'll have to worry about then.
No, that makes total sense. So in my head, I'm just collecting data for between these two approaches, right? The long-lived cluster and the disposable cluster. I think that's really quite interesting. So just to double check, the Kubernetes upgrade that you were talking about, Prakash, within the long-lived cluster, I'm assuming that's kind of an in-place upgrade of the Kubernetes.
In-place operator, that's
well,
right.
No, sorry, in-place upgrade, yeah. Kind of.
Yeah, in-place upgrade, yeah. In-place upgrade, yeah, that's right.
And to and Spiros, just to make sure I'm not misrepresenting what you were suggesting, I guess in your disposable cluster world, you just have the old and the new next to each other, and you route traffic between them, sort of outside of Kubernetes, effectively.
Yep. So you control the percentage of flow in the proxy level, and then gradually you remove backends from that run in the old clusters. So all this can be done, all this logic could be called the service mesh logic that could be served from a single cluster or many, both with advantages and disadvantages. At least coming from the world with OpenStack Magnum that we struggled for some time to implement in place upgrades, and seeing that the success rate is much higher when you dispose either old nodes or old clusters, because even with Magnum you can, or just not only Magnum, like this is a pattern you can follow with the cluster API, for example. You can have a pool of nodes, a node group in Magnum terminology with version X, and then you can add another one with version X +1, and do the non-in-place upgrade like this, which is in place in the same cluster but not in place per VM.
So for this approach, this individual user kind of needs double capacity for some time, I guess, because they've got the old and the new next to each other.
It's not it doesn't have to be double, right? It could be per VM, like it's not necessarily double. You will have double the control plane for sure for some time, but if you have many clusters, even for that it's not double. If you have always five clusters for your production workload, you can replace one by one.
It's double per individual cluster and application, but not double in aggregate, I guess, right?
You need some extra capacity anyway.
Additional capacity required for that. So if you were to use Kubernetes, if you were to use 3 Kubernetes clusters for this setup, so you have Kubernetes doing the proxying at the top to the Kubernetes below. I don't know if that's even really a thing.
It's possible, definitely.
Yeah, I mean, basically, I'm saying run your proxy inside Kubernetes. Then you would have to do an in-place upgrade of that top Kubernetes, I guess, right? Or would you fail a bit over?
You can do that. You can do that, or just replace it by another one. It depends also in the infrastructure below, right? With Octavia, it's easy to add another one, and your Octavia might support or not virtual IPs. You can even move virtual IPs or having DNS load balancing. So it also depends on the infrastructure below and the complexity you want to add. But another point I would like to add in favor of disposable clusters is that if you have this kind of pattern, you can also ensure that at any time your disaster scenario, a recovery from the disaster scenario is in place, because if something fails, you can easily put everything back together very fast, because you have streamlined this process. Because if you have a big cluster, maybe or maybe not, it depends a lot on that cluster, and assuming this is always there, which can be true. It doesn't mean that it will fail or anything.
That sounds good. Prakash, you had a question.
Yeah, once you said Kubernetes hierarchical implementation of cluster, that's interesting to me. So I was just wondering, did anybody try that, and what exactly you do to the HCD then? Does it have 3 HCDs? And okay, we'll get there. Yeah.
I have exactly the same question. Did I just invent that in my head, or is someone doing it today? My developer at heart is strong. It's just more turtles, right?
Well, we have done that definitely, not for production, because we invested more in the networking infrastructure and having Tungsten Fabric behind Octavia, the Octavia API. But we also even have even more skewed patterns, like this work was discussed between me and Thomas from our CERN team, to have virtual kubelets that are clusters essentially behind. So the level of multi-Kubernetes hierarchy can go in very, very deep. It's up to you. But
Yes,
for the question of having the proxies running in the top level, it's again up to the network. So how do you get the traffic into the backend clusters? You use the host port or the node port or service type load balancer, so that the front-end clusters can talk to the backends. There are teams that are doing this, like one of the experiments at CERN is doing this. So they run the front ends in one cluster and the backends in another one. And there they're using host port, not node port, like just host port for the English controller for every cluster to go to the deeper levels.
Yes, but for production, this will be a risky one, I think. It is. Would it not be better to use Envoy or a service mesh in this case?
So I think we should probably move on to talk about networking specifically.
Okay.
Because I think that's a really good thing to dig into. We've got a question, for example, on this on the Zoom chat. Actually, this question's about Edge and Kube Edge and things. Do feel free to raise your hand if you want to say something, or oh, actually, we haven't turned that on.
Oh.
Feel free to put something in the chat and say hello if you want to.
That was me. This is Beth. Yeah.
Hey, Beth.
Yeah. Yeah. Kube Edge has come up a couple times. I guess it's a new Kubernetes product. I know almost nothing about it, but it seems like something worth pursuing. And I don't know how much I mean, I'm obviously interested in Edge, so, that's why I'm interested in it, but I don't know if others know anything about it. So just throwing it out.
Let's put that on the back boiler. If someone wants to speak up about that, feel free to pop something in the chat. So I was going to talk about networking options, and this speaks a little bit to the question around HPC and containers, but I'm going to stay straightforward on the networking to start with, I think. So I'm just wondering if people wanted to share. So actually, we should just talk about the poll quickly. So the poll showed that about 30% of people are in production with Kubernetes and OpenStack. So I'm talking definitely to that 30%. Please do speak up and tell us what you're up to, and do share. That'd be great to find out more about that. And the reason I say that is because 40% of the people are here to find out and find out about what you did, basically. So that'd be awesome. So I guess one thing I wonder if people had a take on was like double encapsulation. And what I mean by that is if you're running your VMs inside a private network, be it created by Magnum or whatever, then, and I think, yes, someone's going to mention Courier, which would be good to talk about. In that particular case, you often then have like another network encapsulation happening inside that VXLAN. So you get this double encapsulation. And indeed, some people thinking that they get VLANs to their host actually have double encapsulation in the switch, if your switches are doing VXLAN for their L2. Not that that affects the NIC offloading. But we've certainly seen VXLAN performance within the virtual stack be very poor if you don't have good offloading within your stack. But I don't know if people have got particular stories of that, or whether everyone's just muddling through, hoping for the best. I'm curious.
So for performance for the VXLAN or another type of encapsulation, we noticed that the underlying architecture must be well thought in advance when you deploy your application. So if you have something low latency, it certainly must not cross subnets because the performance impact is great. And if you do VXLAN encapsulation across them, you will notice quite a performance impact. And I would also like to add that if you're using the pattern that we were discussing before and you have a service meshy kind of architecture, you can assume, or you must trust a bit the networking infrastructure underneath it, and in general the infrastructure making this kind of decisions. So it depends on which API you want to put your trust and confidence on. So either in your in-cluster network or the infrastructure network, because you will consume a lot the host network. And always, I think Tim Hawking from one of the creators of Kubernetes was mentioning that initially Kubernetes was coming out from Borg was mostly running containers, and the team implementing the solutions. So for putting traffic and passing the traffic to those containers were different teams. So the architecture there must be of the underlying infrastructure, and your application must fit a bit. Like you must also take into account the underlying architecture.
So there was someone talking about disabling port security, which always piques my interest. I don't know if they wanted to talk through that.
Yes, hi. I'm Chris. That was primarily for replicating a bare metal setup to OpenStack, and I wanted to be as close to bare metal as possible. So I disabled port security at all, and I was able to talk. So port-to-port communication does work directly. I have a virtual switch within that, like a Cumulus switch, doing BGP in there. And when there is, because I wanted to replicate the hardware setup as close as possible, and that did work. So the only thing you have to take in consideration is how to propagate the routes, but well, that could be done by Calico or by kuberouter, depending on what you need. You could also go the way that you add the allowed address pairs. When that matches, it should be possible as well without disabling everything. But it's it's a little bit more clumsy than just disable it when you're close to bare metal.
The IPs in there, would they be would you have to repopulate that with all of your pod IPs, or well, the pod IP range? I guess.
As far as I know, you can update that with CIDRs, but then you have to use the host CIDR or.
Okay.
Or yeah. Well, you can even use the overall what you configured as cluster CIDR. That should be possible, but I didn't test that. With port security disabled, it works.
And so in that particular case, were you involved in running the OpenStack that you were running on top of?
I'm running the OpenStack as well, yes. So I'm running the OpenStack underneath, and I'm running the Kubernetes on top of. And the Kubernetes is there for running OpenStack, but on bare metal for sure. But it was just to get the deployment clear.
Nice.
And get some kind of environment where we can do automated testing without having to have bare metal nodes for having a lab where I can test my code on.
Yeah, so I guess that's a good point, is that if your production is bare metal, then you kind of need the dev environment to be the same networking setup, otherwise dragons.
Yeah, definitely. Yeah, I even created, as I mentioned, Cumulus switches. We run Cumulus in production as a switch, so a pair. And I installed Cumulus appliances into OpenStack and used them as the switch where I connected 2 legs of the VMs to, and then I have a management link where I can SSH into, and everything else is done via BGP over the Cumulus switches. Like
okay, so
like a fabric setup.
Oh, so in your, and I probably got too many levels wrong. In your bare metal cluster that's running Kubernetes, I guess is running OpenStack. In that particular case, you've got bare metal machines with the Cumulus switches in production. So this is the dev cluster. Got you. This is which presumably is running on the other one. Yeah. Okay. Yeah.
The Kubernetes with the Cumulus is running on bare metal.
Yeah.
But I lifted everything into OpenStack to have a dev environment there. So with the 2 switches and the fabric network and BGP set up everywhere.
So in that case, your the network on which that you've got the port security off or allowed IP address pairs, depending on whether you do that, that network, physically speaking, on the wire, is that like VLAN encapsulation, or is that just a generic...
Well, underneath, yes. So we use Open vSwitch underneath in the cloud, yes, with VLAN encapsulation. But the path between the virtual switch and the VM is just plain L2. And also all traffic between the pods is just L2 traffic direct that's directly routable over the switches for sure, because of what we have in bare metal.
Okay, cool. Very interesting.
Yes, sure. Very interesting. I also was thinking through, but so don't you use IP virtual services to segregate the overlay underlay? Or just use the bump traffic? I don't know where exactly the distinction between underlay and overlay comes in this case. What you have been describing, I'm just a bit lost in this thinking through. So if you do everything in the bare metal and with what you call Cumulus and everything in the underlay, that means you have everything at the physical level being done with whatever you have, whether it's a VLAN or with real-time Linux and all that, with all the drivers and all, with kernel drivers and all. But on the overlay side, you say you're using BGP to go across. What happens to your overlay side?
Again, the last words. What happens to?
Whatever overlay you're doing, you don't do any overlay, you mean? You just focus on everything on the underlay or bare metal only?
We are focusing there on the bare metal Kubernetes where we run also OpenStack on top of. But this dev setup, what I was referring to, is really just matching physical hardware as close as possible. And it's a traditional fabric setup, which makes running Kubernetes a little bit more difficult. So we have 2 interfaces in each node. so each connected to one of the switches, and then we have a service IP or a canonical IP, which Kubernetes kubelet uses as the node IP. But we have both ways where the traffic can come through. So that's configured via equal cost multipath. So we can saturate both links, and if one link goes down, everything works over the other one without any huge package losses.
Okay, so you're ensuring the reliability. Okay, got it. Thanks.
So I think a good segue from this conversation is to line 130 in the Etherpad. And partly going to hit on the next topic as well. So we've got about 10 minutes or so left. Is bare metal versus VMs? I think, Christoph, you made a great point. Like, you know, I guess you're using bare metal for production and VMs for testing, effectively.
In this case, yes, but that's only one part. We also use Kubernetes on top of OpenStack that is deployed by Kubernetes, which is kind of cluster API machine controller. But those are two separate things. But the bare metal stuff we use especially to be in edge locations, in fact, where we come with a very low footprint of machines. And so we even install Kubernetes component onto the Cumulus switches so that we don't have to, so that the customer has as much compute capacity available to him as possible. And for some customers, we run OpenStack on top of that. So but we need some kind of management plane, I would argue, to deploy stuff on those edge locations, and we decided for Kubernetes to do that.
So so the cluster API perspective, your kind of kernel of the cluster is basically the Cumulus switch, I guess. Is that where you do the initial?
No, the cluster API part is separate. That's kind of alongside.
Oh, that's for the other side. Okay.
That's for the other side. You can technically do all the stuff with cluster API on bare metal as well. We decided against that because the setups are very static. So we come with a low footprint, like let's say 4 nodes, or that's sometimes when there comes an OpenStack setup, it's maybe 20 nodes, but it's fairly easy. We don't need the cluster API capabilities. It's just a Pixie boot and kube control join. That's it, basically.
Oh, that's a good point. The restrictive capacity in the edge kind of means you want all the nodes on, right?
Yeah, well, we have some restrictions there, especially around cooling and power. So while cooling is the most important part. I mean, we ship racks there where we have much more capacity. So small they are. I don't know how huge they are. Maybe.
Oh, so half rack thing.
Well, it's a half rack. It's a special purpose rack. But with the cooling on top of that, but we can just put just make it half full of compute nodes because of cooling capacity. So yeah. Those are the limitations on the edge. So you don't get enough power, and you don't get reliable internet, and you don't get enough cooling.
That's interesting.
I suppose sorry, Prakash, go ahead.
Yeah, that's interesting because how much do you need to maintain some temperature levels which are different from 20 to, let's say, 25 degrees centigrade? Or is it?
I'm not so much into how much capacity we do have. Mm-hmm. I should have prepared because we have a sheet. We have a sheet about that. But the thing there is, those edge locations are not in a data center. They are meant to be at an industrial building on site, like to. So they might run some software on top of it to measure their production line, make photos of the parts that come out, push them into the application, and find out if they are correct or not. So they are in the building. They are not in a data center. They are just in the construction site building. And,
I see.
So and therefore we ship our own cooling on top of that. But well, it's limited.
Yeah, so it is air conditioned basically. You need to condition the air. Okay, so power goes in that, and on top of it you have servers that consume power, and so power limitation will hit.
Power
And
limitations for
yeah,
cooling
and it's
and compute.
correct. Get it. Thank you. Thank
So,
you for that.
so I'd love to dig into. I guess the other point I made. Sorry, I was going to is you were saying about the dodgy internet, which is a strong feature of the edge. And there's the Edge working group for OpenStack, by the way, has some really nice architecture diagrams about this, which are really useful to describe that. This is great to talk about. I guess that's why you've got a Kubernetes controller on your Cumulus switch rather than outside of the edge, right? So your Cumulus.
Yeah, indeed.
Kind of
Everything. We want to have everything on site without any connection to the internet. So the future plans also include offline upgrades, like someone's coming there with a USB stick, and and all of the images that are needed for the Kubernetes are in that, and so we can update it in place.
And my assumption is that's more that's like a bandwidth constraint. If you're having to pay for that bandwidth, you send someone with a USB, right?
Yeah. Or not just that. It could be, or most likely, well, it is internet connection, because in Germany it's kind of poor where the industry lives, which is sometimes far away from big cities. But more important, there might be compliance concerns, so that people don't want to be connected at all.
Oh, okay. Yeah. Okay, that's a good point. We probably should have dug into that with the container images, because that's a big one where you need to rebuild on site. So I think we're almost out of time. I guess I was wanting to touch on the HPC thing, because we were basically saying about bare metal versus VMs. And one of the things we've been doing is passing through devices, so PCI pass through into the VM to try and get more performance out of the VM. And the idea to do that is really, if you take the bare metal approach, so you just give an untrusted user the physical machine. In the bare metal sessions, the previous OpenDevs, we was talking about the security problems therein. So these VMs give you that little bit more feeling of the security. So and the two things I'm thinking about here are SROV. So if you wanted RDMA networks and high speed throughput, you can actually have the virtual function passed into your VM, which is then given to the host networking. And for the GPU in a similar kind of way. I'm wondering if people have been exploring any of these things to try and get that, to remove the delta between bare metal and VMs when hosting Kubernetes. I don't know if anyone's got anything on that. I'm going to probably drop a coworker in it because I think he's in the call. Bharat, are you on the call? He's probably gone for a coffee. What I was wondering is that we actually hit some issues where SROV only works once in some cases. So if you pass in the virtual function, then you can't get Kubernetes to manage your virtual function. So you have to pass a physical function into the VM for Kubernetes to then manage virtual functions on top. And I was wondering if anyone's actually worried about this, or if it's only me worrying about it. I mean, Kurt, maybe you asked, was it Kurt on here that asked a question about, maybe Martin was going to speak up there, about HPC and Kubernetes. I was wondering if people wanted to talk about any of the performance concerns there. Kurt, you said yes. That's good. Feel free to share your perspective here. Oh, interested in GPUs under Kubernetes and Magnum. But it is, I don't know if the CERN folks wanted to talk about GPUs. Certainly I've seen GPU pass-through into the VM work very well to then use the host GPU within the VM. But we do have this nested problem as well, and that you can't do, well.
So for GPUs or vGPUs for Kubernetes. At the moment, as you mentioned, we have the pass-through solution in place, and then we deploy the NVIDIA, because at the moment all our GPUs are NVIDIA. We deploy the device plugin as a daemon set to expose it to containers and the Kubernetes API. We're doing some work for vGPUs, but we don't have any
interesting.
experience with Kubernetes so far yet. So, and also some info about this this plugin. Since we consume Fedora CoreOS now, and before we were consuming Fedora Atomic, the drivers need to be built for a certain version of the kernel. So we had two modes. One is that we tag images that have the kernel modules inside for a specific kernel plus NVIDIA driver version. And the other mode is that if the daemon set gets deployed in a node that the kernel version and the driver that don't match, it will try to build in an init container the kernel module, and then
Yeah, that's
the normal container.
And that's probably a good place to stop, actually. Spiros makes a very good point there that kernel, inserting kernel drivers into your well, cut down OSs that are running your Magnum clusters is an interesting dark art. I suppose the best thing to say is that we should probably talk about this within the scientific SIG. There's a working group within OpenStack that is very specific to HPC and scientific workloads. We should.
But all these concerns for kernel plus version, like, it's not.
No, that's not specific for sure.
Fedora or what we have chosen, but yeah, with Ubuntu or CentOS, you will face similar problems. Maybe slower speed in the kernel releases, but still, the problem cannot be solved by building all combinations.
Yeah, that's a good point. And yeah, I suppose the convergence in AI workloads all needing GPUs and other things is kind of meaning that this is becoming everyone's problem rather than a niche problem. Oh, well, Alison, I guess we're timed for, I don't want to take everyone's break away.
Yeah,
I'm pretty sure I did last time I moderated.
It was a great discussion, though, so thank you for moderating. But yeah, so we're going to take a 5-minute break. We'll return at 10 minutes after the hour to talk about OpenStack Cloud Provider. So come back in 5 minutes and we'll play some music, and if you want to hang out, but we'll return shortly.